In this video, we solve problem number 3 from quiz number 1. It's a very simple problem, so this is going to be a very short video. We're asked to classify the differential equation by type, order, linearity, homogeneity, and nature of the coefficients. And first of all, when we're classifying it by type, that's when we're deciding whether it's an ordinary differential equation or partial differential equation. These derivatives are given in prime notation. When you see that 6 in parentheses, that means that's the 6th derivative of y with respect to some variable. From context, we can see that the independent variable is x. So this is the 6th derivative of y with respect to x, and that's the 3rd derivative. Since those are ordinary derivatives and there are no partial derivatives anywhere, so we don't see that partial notation from Leibniz or subscript notation, we know that this is an ordinary differential equation. The order is the order of the highest order derivatives. This is a 6th order differential equation. When we're trying to decide whether a differential equation is linear, we are looking for products involving y and y's derivatives. We're looking for composition of functions involving y or y's derivatives. We're just looking to see if this fails to fit into the form of a linear differential equation, which would just have functions of the independent variable times derivatives of y with respect to, the independent variable, and then we just have a sum of those. So we'd have a function of the independent variable times a derivative plus a function of the independent variable times another derivative plus the function of the independent variable times a derivative, and so on, and then eventually you'd have a function of the independent variable only on one side. Now this time it's not in that form, but notice that we have a natural log of x times y. Since y, that's our dependent variable, is inside the logarithmic function, that makes it nonlinear. Anytime you have a composite function involving the dependent variable or the dependent variable's derivatives, the differential equation is nonlinear. And then for homogeneity, that's when the right-hand side is 0. When after you have moved all of the y terms to one side and all of the terms involving the independent variable only to the other side. Well, this term involves y, and this term involves y, and this term involves y. Since this is on the wrong side, I want all the y's on one side, I just need to subtract that from both sides. And then I would have this. So then I look at this and I say, okay, if all the y's are over here and I don't have any terms involving x only, then the right-hand side is 0 in that case. If the right-hand side is 0 and all of the terms over here involve y or y's derivatives, then the differential equation is called homogeneous. So this is a homogeneous differential equation. And we want to know the nature of the coefficients. Are they constant coefficients or are they variable coefficients? Well, x squared plus 1 depends on x explicitly. So this is a variable coefficient equation. If this was a 2 and that was a 2 and then that was a 2, it would be a constant coefficient equation. So this is a 6th order nonlinear homogeneous ordinary differential equation with variable coefficients.